Uh, Hello all. So today, today we will continue our use case sales forecasting. Yesterday we have done just a second. Yesterday we have done till here. Okay, and then I made another video day 7. But due to internet issue, that video is not uploaded completely. Okay, so I have deleted that video, and from here we will again start with exploratory data analysis because this PDA part is very important, and I have seen that video is for 17 seconds only. So I have decided that at day 7 I will start again. So for this, let's connect and we will run cells uh, code till this cell. Okay, uh, so it is connected now. Okay, so now it is connected. These things we have discussed. So I will just simply run these cells. Till now, we have already done. So you can check there. Okay. So now the first question is how are the stores distributed based on their types? So to find the stores distribution based on their types, we will group the data. For grouping the data, we will use group by store and find type dot and okay. So for different types of for different okay. So we need to group by type actually. Group by type and for each type how many stores are there, so we will use an unit. Okay, so if we will run this code, it will show that type A has 22 stores, type B has 17 stores, and type E has this amount of stores, that is 6. Now plotting the count and proportional distribution of the store based on its type on time. So same value we will visualize. Okay, so we will use bar plot, and for proportional distribution generally we use pie chart. There in pie chart we or donut chart. There in pie chart and donut chart we show in percentage, okay, or proportional distribution. So this is we are defining the figure, and this is the code. You can pause the video and look at it. Okay. So we are grouping by type, and then similar finding the number of stores. Then we are plotting a bar chart, and this color map we will use, and font size will be 12. And then we are providing X, Y label title, and then for second plots, subplot 1, comma 2, comma 2, we are creating pie chart. Okay. And how values, this auto pact is used to show how values should be seen to us. So it will show like this. Uh, so this is the plot. So type A, type B, and type C, and on y-axis it is showing the number of stores. And this is the pie chart, which is showing that proportional distribution means type there are 48.9% of type A store, 37.8% of type B, and 13.3% of type C stores. What are the observations? Stores belonging to type A have the highest number of counts with 22, accounting for 48.9% of all the stores in the data. And same thing it is written here. Nothing special, no need to go through every word actually. So then we now know the proportional distribution of stores based on their type. But can we find some other relationship between the other features? So we will do detailed EDA in this, and we will try to find a relationship between other features. So question number second is the is the size of the store related to the type of the store? So we need to check that size of the store is related to the type of the store. So these are so what we will do? We will create a matplotlib figure. So plt dot figure, and fixed size will be 8 by 8. Fixed size equal to 8 by 8. Now we will create the box plot using Seaborn, and we will use sales data frame and winter as palette. Okay, so let's create SNS dot box plot and sales data frame, and on X we are checking the size of the store and type. So on X we will provide type, and on Y we will provide size, and then palette will be winter, and width will be zero point 0.8. Okay, now plt dot x label, plt dot y label, and plt dot title. So on X label, we will mention like type. On Y label, we will mention size, and on title, we will mention this. Here in X label, Y label, and title, we can give font size also. So I will give font size as 14 here. Okay, and here same font size 14, and here we will give font size as 16. So this is all. And here on axis type and here size, and this should be the plot. So if we run this plot, you can see this is the similar thing. So what are the observations here? In plot, this line is the median value. Okay. So if you see that for type A, it has the largest size. Okay, this is the type A, and this type B is smaller in size from type A but larger than type C, and this type C has a smaller size. So same observations are written here. Type A store have the largest size, followed by type B store. Type C has the smaller size. So there is no overlapping area in size among A, B, and C, which means that type is the best predictor for the size of the stone. So on the basis of type, we can say that these are the best predictor of size of the stone. Or we may infer that type might be the proxy or alias for the size of the stone. Means for the size, type is the another alias. Okay, so these are the things. Larger store might have higher weekly sale. So there may be chances that stores have higher weekly sale. Can we see a relationship between type and weekly sales of the store? So let's go ahead. Does the larger size store have higher weekly sale? So we will plot between the size. So for size we will use type and weekly sale. So if we check that what is the relation between the weekly sale and size of the store. So for this PLT dot figure fixed size 8 comma 8. Then SNS dot box plot for sales data frame. On X we will have type, because type is the is like alias for size. Okay, and then for Y we have weekly sales, and then width we ask to keep point 0.8 and show flyers we will keep them false. Okay, so this flyers show flyers is like these values, these outliers. Okay, so if we keep them false, so these values will not show in the graph. So these are the all the things. Then X label, Y label, and title. Okay, okay, copy it from here. X label will be type and Y label will be weekly sales, and title is the relationship between weekly sales and type of store. Okay, so run this. See, this is the type and this is the weekly sale. So uh, A has higher weekly sale than B, and B has higher weekly sale than C. There is overlapping in this box plot, but from this median value, we can identify this median of this is higher than median of this and median of this. So median of A is the highest and C is the lowest. Also, the order of median of size and median of sale is the same. That means the stores with the larger size have the higher sales record. So this is the order of sale, median of sales. Okay, and same was the order here, the median of size. So we can say that higher size uh, have higher sales record. Now, question 4. Is there a strong positive correlation between the size and weekly sales of store? So, for finding the correlation, we will draw a scatter plot between the size and weekly sales of the store. So, what we will do? Sales data frame. Here we will use like pandas library for plotting. So in pandas we do plot, we create plot like this. We mention data frame name, then dot plot, and in this under kind option we can mention like we need scatter plot. Okay, and then we will for transparency we will mention alpha s 0.5, then color. So color will be orange. Just a second. I am just checking what are the options available in this. So it is color map. Okay. So color will be orange here. And then we have size, fixed size. Fixed size will be 10, comma 8. So we have covered all things. And here on x-axis we will keep size, and on y-axis we will keep weekly sales. So copy weekly sales from here. So this is the plot. Now we will add X label, Y label, and title. ELT dot X label, size, font size, 14, and then ELT dot Y label, and this will be PLT dot title. So Y label will be weekly sales, and title will be relationship between the weekly sales and size of the store. So will be the title. Run this. So you can see that there is not any significant relation, because here size if like line is like this, so we can say positive correlation is there, And if it is going like this, then we can say that no negative correlation is there. But I am not able to find any correlation here. So based on this plot, the result doesn't don't look so good. We cannot infer any distinct relationship between size and sales. So there is not any distinct relationship between size and sales. It seems a bit linear. Okay, so for example, for this size, you can say that weekly sale have different values. So we cannot say that if for this also. So we cannot say that if size is increasing, then sales is increasing. So nothing like that. That's why we are seeing it seems a bit linear. How does each store perform on the basis of weekly sales? Uh, Create a matplotlib. So now we will see that how each store is performing on the basis of weekly sales. So PLT dot figure fixed size 19 comma 7 SNF dot box plot sales data frame. Then X will be we are create checking each store performance. So we will keep here a store, and on Y we will have weekly sale. Okay, now we will not show flyers for showing outliers. So show flyers will be uh, oh, false, and then we will palette will be rainbow. Okay, and then okay, this much is sufficient. Then we will add X label, Y label, and title. Here for title, we will keep font size little bit higher. So X label will be store, Y label will be weekly sales, and this is the relationship between weekly sales of each store with respect to the type of the store. So type is also coming. We have not added type in our plot. So store is added, weekly sales is added, and I think we need to group the store or group the box plot by type. So for this we will use hue, and hue we will mention type. So run this. Okay, comma should come here. Okay, another mistake is there. That should be flyers. Okay. Now you can say that store one is one comes under type A. So this is the then store two, then store three comes under type B. So this is the distribution of weekly sales of this different stores. Same thing you can see here that if a store belongs to type A, it has higher sale, and if a store is belong to type B, it has lower sale, and if it is belong to type C, it has lower sale. Some one or two exceptions are there. For example, this store 10, it is type B, but it has higher sale. Okay, so one or two exceptions are there, but rest same all other follow same pattern. So each store has a distinct distribution of weekly sales throughout the dataset. Most of the type store have higher weekly sales record than other type stores. Store can be the variable giving important information on weekly sales. So store can be the variable giving important information on weekly sales. But it is including so much intrinsic information. So store is yes, this is right that store is giving information on weekly sale, but store word itself has lots of things, information attached to it, like type of the store, size of the store, and in which department sale is high. Okay, because every store have lots of department. We need to segment this information into distinct flows. So we will go more deeper into our ED now. Uh, Now the next question is, does the weekly sales for each department vary with the size of the store? So they are asking, weekly sales of each department vary with the size of the store. So we will create a plot for different department, and for each department we will check for different size of store. So I will show you, then you will understand. PLT dot plot, sorry, PLT dot figure page size. We will keep 13 comma 16. We are taking here 13 comma 60 because the department number of departments is very high. So we will create this plot horizontally. So that's why. So SNS dot box plot, then sales data frame. X will be the X will be the weekly sales. Okay, and one second. X will be the weekly sale. Y will be the department. Department, and then we will group this by by type. Okay, and then orientation. So where is that option? Orientation. Y-N-T A. Here orientation is horizontal. Then show flyers will be false, I think. Show flyers will be false. and nothing else. Okay, so now we will add x-axis, y-axis, ELT dot x level. X level will be weekly sale because on X we are mentioning weekly sale because department number of departments is really high. Font size 14, then PLT dot Y level, and on Y level we have on Y axis we have department font size will be 14. Now PLT dot title. Title will be weekly sales of each department with respect to the type of the store. So in this we have weekly sales of each store with respect to the type of the store. So for each department we will see same for in different types of store. Font size is 16. So run this. It is running now. Uh, it is taking some time. Okay, it is giving one error answer. So actually it should be support value H is not valid orientation horizontal. So it should be orient I think, and here it should be H. Okay, so this will be like this. Let's this cell stop. It is taking a lot of time. Can we stop this? Okay, it is stopped now. Try to run this again. Wow, it ran successfully now. So here you can see that. Let me show from here. Here we have on y-axis we have department. So for department one, you can see that type A is higher sale, then type B, then type C. For department two, type A has higher sale, then type B, type C. Same thing is here. So some one or two exceptions may be there, but for remaining, in all departments have higher sale in type A, then type B, then type C. Okay, so this plot from this plot it is clear now. Can be clearly we can clearly observe that the department belonging to type A store have the highest sales record. This can imply that departments at the larger stores have higher weekly sales record than those at the smaller stores. Okay, Uh, so it is clear. Now, this is for my hand only. Now we have question number 7. Do the holidays impact the weekly sales of the store? So we will see that what is the impact of holiday on weekly sales of the store. So PLT figure fixed size will be 19,7. Now SNS dot box plot sales data frame, and then on X we have um, store. On Y we have weekly sales, and we will group our box plot by holiday. Okay, so for grouping we will use view, and then uh, is holiday is the column. So we will use is holiday. Mention here is holiday. Keep show flyers as false, and palette will be ascent. PLT dot X label, it will be store. Font size equal to 14. PLT dot value, it will be weekly sales. And then we have a title. So PLT dot title, and weekly sales of uh, each store for holiday and non-holiday weeks. So if any week have holiday, what will be the sale? And if any week don't have holiday, then what will be the sale? So font size will be the 16. So this okay. So you can see that for first store, if holiday is not there in green, and if holiday is there, it is in light purple color. Okay, and you can see that when holiday is there, there is a slight increase everywhere. Okay, very slight. It is very little, but yes, there is higher sale. So there isn't significant relationship between weekly sales of the store for holidays and non-holidays. But we do see higher weekly sales soaring during the holiday weeks. Okay, let me connect the chargers. Yes. So now question number 8. How does the weekly sales vary for each month? So now we will see that for each month, what is our weekly sales? So ELT dot figure fixed size will be the 17,7, and then SNS dot box plot, and sales data frame. For X we have month actually. Okay, and for Y we have weekly sales. Now Uh, we will disable this flyers and for X label, Y label, and title we copy from here to edit as per requirement. See, these code you can save somewhere, okay, and use in your coding. So whenever you require, you need to change this data frame name and this X axis label and Y label. Then you can use it. Okay. So weekly sales during each month. Okay. Let's run this. Okay. So you can see that in the first month, sale is lowest. In January, we have lowest sales, and in remaining month, it is looking like same only. And in December, there is slight increase in sale. So month 12, that is December, has the highest sales record than any other month. This might be due to the fact most people do Christmas shopping. And in January, there may be the lowest sale, maybe due to New Year resolution. See, these types of things, when you are doing in real, you discuss with your client. Okay, so client have may also provide better understanding means why there is decrease in sale. So these points you need to discuss with client also. So they may also provide much detail in this. Now, question number 7. Does the store size has an effect on weekly sales of each month? Okay, so now we will for each month we will see the sales in uh, different size. So we will copy same code here, but we will group it by size also, type also. So you will be type. Okay, and month, weekly sales, and weekly sales during each month with respect to the type of the store. So run this. Okay. So you can see that for in each one, same pattern is there, like type A is highest sale and type B and then type C. Again, we can see that type A is to have highest weekly sale record for each month. This means that a larger store have higher sales record each month than the smaller store. Post data processing and analysis. So now, just a second, 1 minute, 1 minute. Okay. So, now we will do post data processing and analysis. Before that, let's take a 5 minutes break. Okay. Or we can do one thing. I will start. Okay, take 5 minutes break only. Okay, so let's resume further. Okay, so we have done a detailed EDA here. You have seen we have explored different things. Okay, so now we will proceed to next part, that is post data processing and analysis. Now, in that we will do the encoding of categorical data. So, type column is okay. One second. Is data frame dot add. Okay. See here, what are the categorical column? So you can see that this is holiday is like binary column, and this type is a categorical column. Okay. So and this date column is date time. So a type column in the data set contains categorical data. It has three distinct values A, B, and C. So for this type column, we will do a dummy encoding, or we also say one hot encoding. In I will show you what is one hot encoding for type A, and this date column. Actually, we don't provide a date column in our machine learning algorithm because they don't process this date column. So we extract our required columns. I already explained in previous videos. Means in yesterday video, I explained that part. So we extract a day, month, and year from this date column. Then generally we drop this date column. Okay, and this is holiday column. We will convert it into 0 for false and 1 for true. Then our data will be processed. So let's proceed. First of all, we will create do dummy encoding for our type column. Uh, pd dot get dummies. Okay, and then in this we provide sales data frame, and also what we need to provide. This is data and prefix columns. In columns, we will provide sales data frame and type. So it is saying that create dummy variable of the type column. Apply one hot encoding on type column using pandas and update sales data frame. Okay. Drop first dummy column using drop first. So see if inside in this type column A, B, C is there. So it will create three columns A, B, and then C. And what is the thing that like if we can like if okay, one second. A, B, and C is there. Okay. So we are doing one hot encoding or dummy encoding. So for example, it, it is A, it is A, it is B, and it is C. Okay. So see here it is A. So we will mention 1, 0, 0. Similarly, we will mention 1, 0, 0. And here we will mention 0, 1, 0. And here we will mention 0, 0, 1. Okay. So see from here we know that it is A, it is A, it is B, it is C. So if we created three columns, if we drop this column, if we drop this column, then you see this is A, this is A, this is B, and we know that this will be C. So that's why we do drop first. Okay, I hope it is clear to you. So we will mention uh, drop first equal to true. Also, we need to mention the type D type. Okay, because if we don't mention D type as in, it will come as true false here. Instead of 100, it comes as true false false, true false false. Uh, so that will cause issue during our model building. Okay, because our model expecting numerical data only. So D type will be int. So this is the complete code which we will use. And here in columns, we will mention only type. So, and also we will show a few rows also here. df dot add type B and type C. Type A is dropped. So run this. Um, okay, 1 second. Let me check. Okay, it should be drop underscore first. Now run this. It runs successfully now. Type B and type C is created here. Okay. Now move forward. Now feature a day extraction from date. So what is it? During data processing, we didn't extracted the date information from date because it wouldn't have helped us during the analysis. But the ML model cannot process date time format features, and hence we need to remove the date column from the dataset before training our models. So in order to conserve the weekly date information, we will create a day column by extracting the day information from the date. Okay, so previously we have extracted the month, but now here month is here. Now we need to drop this date column. So how we will extract, how we will get the weekly information. So we will create new column that is date. Okay, day. Sorry. So sales data frame day, sales data frame dot uh, date dt dot day. Okay, so creating day column in the sales data frame. after extracting the information from date column. So run this and also better show it also. Dot head. Okay, so now this day has come out. Okay, fifth day. Okay. Now a day column is created in the data frame containing the day value from date column. Now we will remove this date column. So sales data frame, sales data frame dot drop and labels equal to date and access equal to 1 and in place equal to 2. Okay, so it will drop this column. So run this. Okay, so you can see that date column is removed now. Okay, this cell I can delete. Date is removed from sales data frame. Converting is holiday to numeric form. So for converting is holiday to numeric form, I will apply lambda function. So sales data frame equal to sales data frame is holiday dot apply. We will apply one lambda function. This is the format of writing lambda function. Lambda x equal to 0 if x equal to false, else 1. So like this, we will apply lambda function here. So run this. We have to check it also. Okay. We have done one mistake here. Just a second. So now, see here we have applied this lambda on this one column only. So that's why this issue has occurred. Just wait for a second. Okay, so here, okay, so we have done one mistake here. So actually, we are applying this on one column, okay, and we are replacing whole data set. So that's why this issue has occurred. Just a second. Okay, um, run before. So it will run till now. Just wait for 1 minute. So now it will be resolved. So it has run till now. Now see this. Okay. So sometime mistakes happen. It's not an issue. So is holiday now it is result. Now we will do data splitting. Now we will split the data set into train and test subset. We will use 80% data for training and remaining 20% data for testing our model. First, we will separate the dependent and independent variables from the data by creating a feature matrix and target vector. So first, we will separate our data into features and target, creating the feature matrix by removing the target variables. So sales dot drop and labels will be a weekly sale only. Okay, so weekly sales, comma x is equal to 1. So this will give x. Okay, x dot add. So weekly sales is removed. Now we are creating y. So sales data frame, and in this we will take weekly sales only. And we will mention y dot head. Okay, so we have created x and y. Now next thing, using scikit-learn train test split function to split the dataset into train and test. So we will do x train, x test, y train, y test, train test split, x comma y test size, point 2. Also mention random state. Random state as keep it 42. Okay, so run this. Now check their shape. So yes, shape is good now. Okay. In training, we have training data. We have this much rows and 17 columns, and for this much rows we have target variable. And in the test set we have this much 84,314 rows. Okay. Now model development and evaluation. In this session, we will build our machine learning models and fitting them with the training data. Okay, we will be building models using all the features of the training set. The most important features of the training set according to the random forest algorithm. So what will we do? First, we will create model for all the features. Then we will find important features, means we will do feature selection using random forest algorithm. Also, we will use k-fold cross validation to validate our models and select the best one. So we are creating a helper function display score. Uh, this will help us in displaying our k-fold cross-validation score. So for k-fold cross-validation, what is k-fold cross-validation? Means for our data, if we say that five-fold cross-validation, so it will split our data into five five subset and train the model on four subset and take fifth set as a target. In this way, it will do it iteratively. Okay, for all the five set. So that is what we call k-fold cross validation. Here we have stratified k-fold cross validation also that we use in case of imbalanced data. If our data is imbalanced, then we use stratified k-fold because that makes sure that the class which has minimum value is is uh, have samples in all the fold. Means we are dividing five data into five parts, so that minimal class should be present in all those five. Okay, so now define function uh, display scores, and as an input it will take scores. Now calculate RMSE for scores in and save in scores RMSE. Uh, for RMSE, actually RMSE I think directly not available in sklearn. So for square root we use numpy np dot square root and we will do MSE mean squared error. Okay. Uh, actually, okay, that score will come from fold only. Okay, so scores. You may ask that why we take negative value here. Because in this case, we will use negative mean squared error. So uh, now print RMSE scores underscore RMSE, then print mean scores RMSE dot mean print standard deviation. IMS scores underscore IMSC dot standard deviation. Okay. this is we have defined our function. Okay. Now jump to baseline model. Uh, okay. This we will cover in next session. Okay. I will start soon, but this part we will cover in next session. Thank you.